Hi all, I hope all are fine. My name is Jeet Tilak, working as an assistant professor in Mechatronics Engineering Department at Hindustan College of Engineering and Technology. Here now I'm going to discuss about the projections of lines. So this line shows you about the projections of lines, the positioning of lines between the horizontal plane and vertical plane. So this is a vertical plane, this is vertical plane, and this is horizontal plane. And between these two planes, the lines are positioned in different ways, like lines parallel to both the HP and VP, line perpendicular to HP and parallel to VP, line perpendicular to VP and parallel to HP, line inclined to HP and parallel to VP, line inclined to VP and parallel to HP, line inclined to both the reference plane. And so first of all, these are the six positioning of lines between VP and HP, as I said. So first we'll see line parallel to HP and VP. So you can see that in this diagram, you have a vertical plane and horizontal plane. This is horizontal plane and this is vertical plane. And you have a line which is placed between these planes parallel to both the planes. So this line A and B is parallel to VP and as well as HP. So when this plane is being turned or unfolded in clockwise direction, so it will look like this in 2D. So the line which is in between VP and HP, if this is seen from this side, that means from the front side, the front view will be projected on the VP. And if the line is seen from the top view will be projected on the HP, that is horizontal plane. So if you represent this 3D drawing in 2D, you will get the front view at the top, that is at the VP, and the top view on the HP. So you will get the front view A dash, B dash, that is the front view of the line which is parallel to VP. And if you just project that downwards, you will get exactly the same length of the line AB, and that is going to be the top view of the line which is parallel to both the planes. So I hope you all understood. So similarly, when it comes to line perpendicular to HP, parallel to VP, the same thing is done here. The AB line, which is placed in between the vertical plane, horizontal plane, is in this manner. So you can see that AB is vertically placed, and you can see the AB line is perpendicular to HP, that is horizontal plane, and parallel to VP. So if someone views from this side, that is the front side of the line is being viewed from here. So what happens is this line will be projected on the VP to get the front view of this line. And suppose if someone goes at the top and views the line AB from the top, he or she can only see a point, okay, from the top. He cannot view the whole line here, because from the top only the point B can be visible. The point A is invisible, so no one can view a line there. There will be only a point, so that will be the top view of this line. Okay, I hope you all understood. And to get the 2D view of this thing, It can be done by the same way I have done here. What you have to do is you have to just unfold this um, HP, that is horizontal plane and clockwise direction, and you can you can just uh, draw this XY line here, and you will get the top front view as a line here and the top view as a point here. So this can be marked as B dash and this can be marked as A dash. So from the top you can see only B and A will be hidden. So you can mark it as A inside the inside the bracket. So this slide shows you about the line perpendicular to VP parallel to HP. So here this line is viewed from the front side here, and you can see the line is placed in between the vertical plane and horizontal plane in this manner. So if AB is horizontally placed in this manner, it is obvious that the line is perpendicular to VP. This is VP, and parallel to HP. This is HP. So you can see that if the line is viewed from the front side, only the point B is visible, and this point A is not visible, and this A finds to be invisible, that is, it is hidden. So from the front side, you could only see a point here. So the front view of this line is only a point. And if this line, which is perpendicular to VP, parallel to HP, is viewed from the top, you the a line is visible with the true length. A line AB is visible. So that line is projected on the HP and it becomes the top view of that line. Next, a line which is inclined to VP and parallel to HP is shown in this figure, where you can see the line AB is inclined to HP and it makes an angle theta, and if this line is viewed from the front side, the inclined line is exactly falls on the VP if it is projected, and the line is with the same length. And if it is viewed from the top side of this line, of the top view falls on the horizontal plane, and the viewer who views the line which is inclined to HP from the top, the B point is nearer to the viewer and the A point is far away from the viewer. So what happens here is when it is projected, the line is shortened. It looks as if the line is shortened. So this is how the line inclined to HP and VP looks like. And if you try to draw this 3D view and 2D, you will just unfold the HP, that is horizontal plane in clockwise direction, and the HP goes down like this. This plane goes down and the VP stays at the top. And as projected here, the line which is inclined to HP and parallel to VP, if it is projected on VP and HP to get the top view and the front view, and you could see the front view like this with the angle theta, which is inclined to HP, and the front view will be A dash, B dash. If the line, for example, if the line is 60 mm or 70 mm, it is going to be the same length in the front view. So this will be the front view, and you will get the top view by just projecting exactly downwards, and you can just find out the top view like this. So this is your views, that is front view and top view of a line which is inclined to HP and parallel to VP. This slide shows you the line which is positioned uh, inclined to VP and parallel to HP. And you all can see that this line AB is inclined to VP and parallel to HP. So the same method is done here, where the HP plane is folded in clockwise direction to get a 2D view like this. So XY is like this. Okay, the reference line is drawn like this, and if HP goes down, the plane is here. The HP is down and VP is at the top. That is vertical plane. Now what happens here is the line which is inclined to VP parallel to HP is projected on the vertical plane and the horizontal plane. As we all know that on the vertical plane you will have always the front view. On the horizontal plane always there will be the top view. So here the line is inclined to VP. So the viewer views from the front side of this line. You could view the point B first because it is nearer to the viewer, and the point B is projected on the VP like this, and A is far from the viewer. So the A is projected on the VP like this. So it looks as if this line is shorter. So from the top view, from the top view is viewed, and the line which is inclined to VP is exactly projected on the HP like this, which has an angle of 5. Okay, which has an angle of 5. So the top view is drawn first. Okay, so this which makes an angle 5. Okay, it is named as AB. So this is the true length of the line, and if this is projected to get the front view, what happens here is the length of the line becomes shorter, because you know the reason. You all know the reason. I have explained here, isn't it? While viewing the front view, it looks as if the line is short, but it is not like that because it is due to the inclination. So this is the front view and the top view of the line which is inclined to VP and parallel to HP. So in this slide, you all can see the line inclined to HP and VP. Now I'm going to teach you how the top view and the front view of a line inclined to both the planes uh, is achieved. Here, first of all, you should take the line uh, inclined to HP parallel to VP, line inclined to VP parallel to HP. So by using a rotating line method, I'm just going to combine these two views to get the top view and the front view of a line inclined to both the planes. So now what I'm going to do is I'm just going to uh, combine these two views as I said before. So the incline the line inclined to HP. 1 minute. So I'll show you. The line inclined to HP, that is A dash B dash, inclined to HP parallel to VP is drawn first. So you can see it is projected to get the front view. So this becomes the front view. So is nothing but this portion is nothing but this one. Okay. The and this portion is nothing but this one. So these two portions are getting these two portions are clipped together, and it forms a structure like this. And now to get the top view and the front view of a line inclined to HP and VP, what you have to do is A dash, you can see that A dash and B2 dash is already drawn here because of clubbing these two things together. So take A dash B2 dash as radius and keep this A as center and cut an arc like this. So it goes and bisects the locus of B dash, and you can just join the A dash and B dash to get the front view of the line inclined to both the planes. The same way, take A B1 as radius, keep A as the center, and cut an arc like this so that it cuts the locus of B. And you can see the point where it cuts, and that point can be joined with this A, and you get the top view of the line which is inclined to both the planes, that is to HP and VP. So this is how the top view and the front view of the line which is inclined to both the planes can be um, derived or drawn, whatever it is. I hope you all understood about the projections of lines, the positioning of lines, and the the top view and front view of lines um, in all the positions between the vertical plane and the horizontal plane, especially the line which is inclined to both the planes. Thank you all.